Good morning class. Today we are going to study about molecular masses of polymers. Since the length of the chain depend upon how many monomers has been reacted to form that chain, uh, and it can vary. So a polymer can have more than 1,000 chains of a polymer, and these chains can be of varying length. As a result, the molecular masses of all the chains will be different. So when we are writing the molecular mass of polymers, it will be the average molecular mass of all the chains present in that polymer sample. So we can calculate the molecular masses of polymers in two ways. One is number average molecular mass and another one is mass average molecular mass. So let's first discuss number average molecular mass. Let's say we have N1 molecules which have a molar mass M1, N2 molecules have M2, N3 molecules have M3, and so on. So the number average molecular mass is defined by this formula. This is number average molecular mass of the polymer equal to summation of product of number of molecules into their corresponding molecular mass divided by total number of molecules. It is determined by osmotic pressure method. Let's understand it in a simpler way. Let's say a sample have three molecules or three polymeric chains which have a molecular mass M1, 4 which have M2, and 7 which have M3. Let's suppose there are only 14 chains in total. So if we have to find out the number average molecular mass, what we will do, we'll take the summation of product of Ni into Mi. So 3 into Mi plus 4 into M2 plus 7 into M3 divided by summation of all the chains, that will be 14. So this is the way of finding number average molecular mass. Now moving on to mass average molecular mass, the criteria like what we were supposing is same. N1 molecules have M1 molecular mass, N2 chains have M2, and so on. So when we are finding mass average molecular mass, it is product of summation of product of Ni into square of molecular masses divided by summation of product of Ni into Mi. So in this case, if we consider the above example only, then our MW will be 3M1 square plus 4M2 square plus 7M3 square divided by 3M1 plus 4M2 plus 7M3. That way we find the mass average molecular mass. It is determined by light scattering and ultracentrifugation method. Now comes polydispersity index. So polydispersity index is nothing but a ratio of your mass average molecular mass to the number average molecular mass. What happens in case of natural polymers? Your PDI is usually 1. Natural polymers mein your PDI is 1, which suggests that all the polymeric chains are homogeneous, or you can say monodispersed. Let's suppose when will these two, when PDI will be 1, when then our MW equal to MN. So based on the formula, how we will identify this, that these two are same. In order to these two being same, our molecular mass of all the chains should be same. Like there should not be chains of different molecular masses present in the system. This will only be fulfilled when all the chains have same length, or you can say same molecular masses. Then only this condition will be fulfilled. So that's what monodisperse means. In case of natural polymers, the length of the chain or the molecular masses of the chains are same. While in case of synthetic polymers, PDI is generally greater than 1, which suggests that these are less homogeneous. Alright.